The last one I want to talk about that doesn't fit under van der Waals, it stands in a class of its own. It's called an ion-dipole interaction. From the name, can you see, what's an ion? Right. An ion is anything with a charge. We know metals like to have positive charges, right? Non-metals typically have negative charges. That would be an ion. What's a dipole? Polar molecule. Okay? When you have an ion-dipole interaction, it's when you have an ion interacting with a polar molecule. Ion-dipole interactions, that's what we have when we have, what is this that I'm writing? NaCl aqueous. What is that? Sodium chloride dissolved in water. Isn't that salt water? Why does salt dissolve in water? It's ion-dipole interactions. Where's the ion? Well, you guys know from Chem 1 that when ionic compounds dissolve in water, they actually break apart as their ions, don't they? So you've got sodium ions and you've got chloride ions. That's what makes them electrolytes. Water is a polar molecule, hence the dipole part of it. So when you look at the Lewis structure for a water molecule, the lone pairs on the oxygen give this area a partial negative charge. Okay, this little squiggly, an O with a tail on the top, means partial. Okay, so this side has a partial negative charge. They will orient themselves towards the cation. But if this side of the water molecule has a negative charge, then that means the hydrogen side has a partial positive charge. So the hydrogens can orient themselves, the positive side, toward the negative ions, and that's how water, for example, can dissolve an ionic compound, a sodium and a chloride. This takes me to a rule, a statement that's called like dissolves like. Have you ever heard that before? Like dissolves like. Some of you have, maybe some of you haven't. That's a very important rule for solubility. Does anybody know what it means? Like dissolves like, or want to tell us? Okay. Like dissolves like, y'all. When we think back to what we've talked about, ion dipole, okay, that's a class by itself, versus dispersion, that's nonpolar. Dipole, that's polar. Hydrogen bonding, that's really strong, that's a special type. If you have a molecule that is polar, like water, water dissolves things that are like it. Water is polar, and water can hydrogen bond. Therefore, if you take another something that is polar or can hydrogen bond, water will want to dissolve it. If you take water and oil, they don't mix because they're not alike. What kind of forces would exist between oil droplets? Aren't they nonpolar? It's just a bunch of carbon-hydrogen chains. Okay, so oil and water don't mix. It's like dissolves like. That is the reason for it. Logan?
You said water is polar, so would it have dipole?
Yes. Yes, water has all three. It's got hydrogen bonding, dipole, and dispersion. Because of that, water is actually known as the universal solvent. Because water can dissolve things that are polar. Water can dissolve things that can hydrogen bond as well. Okay? And sometimes, if they're if they're nonpolar but they have a lone pair on them somewhere, water will dissolve it because it's got that hydrogen bonding capability.